Welcome to this exploration of loudness and how it relates to the amplitude of sound waves. In this video, you'll discover the fundamental connection between a sound wave's physical properties and how loud we perceive that sound to be. Understanding this relationship is key to grasping how sound works in our everyday lives. Let's start with the basics. Amplitude is the maximum displacement of a particle from its rest position during wave motion. Think of it as how far the particles in a medium move from their normal, equilibrium position when a sound wave passes through. For sound waves traveling through air, amplitude measures exactly how far air molecules are pushed and pulled away from their resting state. The greater this displacement, the more energy the wave carries. To understand amplitude better, imagine two different sound waves. A sound with small amplitude causes air molecules to move just a tiny bit from their rest position. This produces a quiet sound. Now, when we have a sound with large amplitude, the air molecules are displaced much farther from their equilibrium. This creates a loud sound. The difference in amplitude directly translates to the difference in volume that our ears detect. Here's the core principle. Loudness is directly proportional to the amplitude of a sound wave. This means that when amplitude increases, loudness increases. When amplitude decreases, loudness decreases. Put simply, greater amplitude equals louder sound. This relationship explains why a gentle tap on a drum produces a soft sound while a hard strike produces a loud one. The harder strike creates vibrations with much larger amplitude. Now let's talk about sound intensity, which is the power per unit area carried by a sound wave. There's an important mathematical relationship here. Intensity is proportional to amplitude squared. This is written as I is proportional to a squared. What this means is that if you double the amplitude of a sound wave, the intensity doesn't just double, it actually increases by a factor of 4. This squared relationship shows us that even small changes in amplitude can lead to significant changes in the energy a sound wave carries. Because the human ear can detect such an enormous range of sound intensities, we measure loudness using a special logarithmic scale called the Decibel Scale. Abbreviated as dB, the formula for sound level in decibels is L equals 10 times the logarithm base 10 of I divided by I0, where I is the sound intensity and I0 is the reference intensity. This logarithmic scale makes it much easier to work with the vast range of sounds we encounter, from the faintest whisper to the roar of a jet engine. Let's put some real-world context to these decibel measurements. A whisper measures around 30 decibels. Normal conversation happens at about 60 decibels. A vacuum cleaner operates at roughly 70 decibels, and a rock concert can reach 110 decibels or higher. Notice how each increase in decibels represents a significant jump in actual sound energy. Understanding these reference points helps us appreciate just how much our ears can adapt to different sound environments. To wrap up, remember this key takeaway. Amplitude determines how much energy a sound wave carries. Higher amplitude means more energy, which translates to a louder sound perceived by our ears. This fundamental relationship between amplitude and loudness is what allows us to control volume in everything from musical instruments to speakers. By understanding how amplitude affects sound, you've gained insight into one of the most important characteristics of sound waves.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.